Great to see everyone today. Yeah, we're really happy to be here in Thailand and hosting DogeCon. Oh yeah, for the slides, right? But yeah, so today I'm going to be talking a little bit about what we're doing at QED on Doge. Because, yeah, maybe we can get into it. I believe it's the up button, down button, it looks like. There we go. But yeah, just a little bit about myself. I come from the more traditional security community before I entered blockchain. I wrote the first virus or worm for game consoles that could spread from one game console to another. So I did a little bit of black hat stuff back in the day, but yeah, I also built ModKey, which is like a modding tool for the mobile version of Minecraft. Yeah, I ran some proof of stake stuff before I got converted over to the light side, of course, proof of work. But yeah, so let's talk about Dogecoin. That's why we're all here, right? Right now, as it sits, Dogecoin doesn't have DeFi, it doesn't have dApps, it doesn't have stablecoin payments, no games, none of all the nice functionality that we see on Ethereum, but it does have one very, very special thing. It has by far the best community in crypto. As we can see all here today, right? Yeah! So it's in this weird place where everyone loves Doge, and there's tons of Doge holders, but after you buy Doge on the exchange, there's not really much thereafter for users or fans of Doge to do. And this stems from the fact that Doge originally was a fork of an old version of Bitcoin, right? And because of that, we don't have smart contracts, and we also have a very strict limitation on the block size, right? So we can't scale too much because we're limited to 1 megabyte per block, which is even smaller than Bitcoin, right? And of course, what do we actually want Dogecoin to be, right? We want to be the best, we want to continue being the best community in crypto, but we also want smart contracts and DeFi and dApps and DEXs and games and support for Ethereum and Bitcoin wallets, and we want all this stuff and we want it to work great. So how do we do this? Especially this last one. How do we get infinite scalability so that people's currency can be used by all the people for transactions like buying pizza, as has been promoted in Bloomberg and other publications that you can do with Doge, right? And I guess one very, very important caveat that I want to highlight is that we also want to preserve the same security that Doge has. While through the years there have been many tokens come and go, no one has ever hacked Dogecoin, right? We know it's a very secure asset. It's backed by the security of Litecoin, enormous amounts of hash power. It's an extremely secure platform. Many would even argue more secure than an Ethereum or a Solana. So can we get all this and preserve that? Can we have our cake and eat it too? Well, let's just look really quickly at what that would look like. If we define it more clearly, what we want to have is something like a zk Validium on Doge, where I can guarantee that if I deposit funds into the zk Validium, it's guaranteed to give me those funds and that they'll always be a non-custodial in my control. So that means no multi-sigs, no proof of stake, none of that nonsense, right? We need to be able to guarantee these things. In addition, I should be able to transfer funds back and forth, use smart contracts, dApps, DeFi, the works, right? And then when I want to withdraw my funds back to Doge, or back to layer 1, I should be able to do that, and no one should be able to stop me. We don't want any Merlin chain situations where I gotta wait a week, or someone's gotta approve me, or I'm relying on this group of 3 or 4 people that maybe have to do a multi-sig. We can't have that, right? Because those people could run away with our Doge, and that was my money. So I guess the old saying is, not my keys, not my crypto, right? Not my keys, not my crypto. Don't send other people your money. That's why we're in crypto in the first place, right? The reason why we like Bitcoin is because I own my own money, not some bank. So we definitely can't go that route. And oh yeah, there's a little copy there that I forgot, which is to put this, or to summarize this very succinctly. Another way we can say it is that the only way someone should be able to steal user funds from an execution layer like QED is if they break Dogecoin's own proof of work. So the only way to hack the execution layer, if it's truly on Doge, should be that you must hack Doge itself, right? We must preserve this. But how do we verify a zero-knowledge proof on Dogecoin? Wait, does everyone know what zero-knowledge proofs are? They're a pretty cool thing. No one? Someone? All of them? Some of them. Okay. So think of zero-knowledge proof as, of course, Mr. Jens Roth knows. Oh, by the way, anyone ever heard of Roth 16? We got Roth right here, the real one. But yeah, so ZKPs, like from a blockchain perspective, they do many things, right? They preserve privacy. There's a lot of other mathematical details. But from your perspective, from a blockchain perspective, you can understand that I can take any really long computation, like processing 1 million transactions, and generate a tiny little proof that proves that all of those transactions were signed correctly, that no one double spent, and I can compress a really big computation to a very small size, which is very important since, again, we've got a 1 megabyte limit here. But the tricks that people are playing around with on Bitcoin don't really work on Dogecoin. Dogecoin doesn't have our wonderful taproot that we have on Bitcoin. We don't even have Segwit. It's a very old version of Bitcoin. We only have a thing called P2SH. And what that means is that we're limited to like 500 bytes for the script. So we're not going to be able to implement this with like weird workarounds for not having multiplication or any of that. We need an opcode. And OPCAT is not going to help us here. We know in the Bitcoin community there's many people that want to use OPCAT. The amount of transactions it would require would be thousands and thousands, if not tens of thousands. So that's not really a good place to start. But again, maybe we can add a ZKP opcode, and just maybe we can fit a ZKP verification inside a standard Dogecoin transaction without having to modify the block size, the maximum transaction size, or any of the consensus parameters, right? Let's see if we can do it. Well, it turns out we can, right? With our wonderful friend, zkRollup 16 verifies. So, yeah, so it's just to give everyone a heads up, it's a little bit jargony, but the main idea here is we can verify a zero-knowledge proof that proves that an execution layer has legally transitioned from state A to state B, which means that we've processed a bunch of transactions, and that this layer 2 or execution layer like QED has transitioned from a Merkle root, or the root state, A to B. So before those transactions were processed, to what the what the balances look like after the transactions were processed. And we meet all the conditions that we want, right? It's soft forkable, which means that if we upgrade Dogecoin and our mining friends upgrade their software, then it just goes live. And it's, miner enforced. So we always want things to be soft forkable. And as I was saying, we don't want to change the script or block size limits. And then most importantly, we want to be able to scale Dogecoin with this. If we're doing Starks with OPCAT on Dogecoin, the ratio of how many transactions you need to verify the Stark compared to how many transactions you're verifying within the Stark is way out of proportion, meaning it's actually hurting Dogecoin rather than helping. So yeah, this wonderful opcode named after our good friend Jens Roth, who will be speaking soon, really does do the trick. But yeah, this is just some technical stuff. This is kind of how the script looks like. Anyone here familiar with Bitcoin script or Dogecoin script? Anyone here? Hey, we got one. Anyone else? Okay. And what is it? There's some weird outputs for staff modification. I forget. But yeah, so basically we put the proof in the witness or unlock script. And then because we can't actually fit the entire verifier key for the proof inside the P2SH script, we also include the verifier there in the witness, but then we store the hash of part of the verifier key in the actual script, which we then, check that hash, is the same as what we expect, and then we verify the proof, and then we drop all the elements from the stack. And the reason why we don't remove the elements from the stack directly is just to make it so that older versions of the Dogecoin software will just process this as a successful transaction. If they haven't upgraded. So this is kind of the soft forkable bit that we want to guarantee. But yeah, so like, if we look over here, do you guys know what public inputs are? Should I talk about this stuff? The tech stuff? Do we want to go into tech stuff? Raise your hand. Tech stuff? Okay, we can do a little bit of tech. We got like the 25% tech stuff. Okay, so if we look back here, if we look on the stack, we'll just hop over here. We've got a couple things. So we've got, over here we've got our proof, and we've got one public input up there, right? Only one. Where is the other public input? Because we said we're gonna have two public inputs, right? So the other public input is what's called the sig hash. So when you sign a Bitcoin or Dogecoin transaction, you're signing this hash, which is like the cryptographic fingerprint of a transaction without the signatures included, right? So that has all the information about what UTXOs are being spent. So if I sent some money to someone and they're spending it, we know who is sending it. And then what the next outputs or who I'm sending the money to. Right? That information is all included in the sig hash. And we include that as a public input to the proof. So we have one public input, which is user controllable, and one which is the sig hash. And the result of that is that that user input, that user configured public input can represent the state of a layer 2 or an execution layer. And then the sig hash helps you enforce, well, actually allows you to enforce, that anyone who deposits money in, they're definitely going to get credited on the execution layer. And anyone who wants to withdraw, it guarantees that their withdrawals are processed. So we're guaranteed that if you put money into this execution layer, you will be able to use it. And if you want to, at any time, you can take that money and withdraw it back to layer 1. You don't need my permission. You don't need my friend Tony's permission. You don't need any. If we're in a plane, you know, God forbid, knock on wood, right? If our whole team is on a plane and then suddenly, you know, MH, what was the one that disappeared, right? So Beijing again, right? If that happens, right, your Doge will be fine. If we don't pay our AWS bill, your Doge will be fine. So again, not my keys, not my crypto. We are fully non-custodial, right? And this is the key. So we just look over this. So if we look at here, you can just see kind of how the sig hash works. Like here you can see the previous block script is determining what the new start state is going to be for the chain, right? And then we have the different deposits from users like you who want to use some DeFi apps or maybe a DEX on Dogecoin. And then this is all used to compute the sig hash. Along with this, here we've got our withdrawals. And then we make sure that the next block script includes the starting state of the next block, which is the current block's end state, inside the script hash. So it's hard-coded in there, so that we know that for the future state transition proofs, we must start at what the end state of the current block is, or we're enforcing that the next block must come after the current block, which makes sense, right? And it forms a recursive, what's called a covenant. There we go. But of course, I talked a lot of gibberish, right, for some of the folks that did not raise their hands earlier. And you may be wondering, am I just talking out of my ass, right? Is this all theoretical? Is this an idea? Is this a great white paper with no code or no implementation? Well, in fact, we've actually built an open source fully end-to-end zkRollup using this. We haven't fully open sourced QED yet, but we took part of the QED source code that was ready to go and sort of cordoned it off, and also built accompanying wallets, block explorers, the works, using this paradigm. And you can, using this opcode, start up a basic roll that allows you to do token transfers, trustless peg in and peg out today. And let's roll the clip. Let's roll the clip. There we go. So you can see I can deposit money in. So over here we have my Doge wallet, and then we have our web wallet. I've now received the Doge on layer 2 by claiming the transaction ID. I'll just stop there real quick. So essentially the way that you claim a deposit on layer 2 is you sign a message from the same key that you use to deposit. So when you deposit, you're going to sign some transaction that says, oh, I want to deposit X number of dollars, or X number of Doge rather, into QED. And we know from that signature, and specifically like the transaction, because you have to include your public key there, that X person, X wallet on Dogecoin made this deposit. So I just have to claim my deposit on layer 2, I just have to sign a message with the same wallet saying, hey, this is me, I want to claim this deposit for this user on QED. Right? Oops. So yeah, I transfer, make the deposit, And you can see over here we have our pegs, because it's called pegging in, or putting your money in. I'll receive the balance on layer 2 by claiming that deposit, signing the message. I've now claimed the deposit right now, and now I can transfer from user to user, as I was mentioning before, and now I can withdraw it back to Doge. So all of this is open source. If you want to play around with it, like, we encourage more layer 2s to come to Doge, or we call ourselves an execution layer. You can call yourself an execution layer 2. We're at such an early stage here with Dogecoin that we just need more people building stuff on Dogecoin. And we are the number 6 cryptocurrency in the world, but we have no dApps, no DEXs, no DeFi. It's about time we come together and build some cool shit. But yeah, so just a little bit of self-shilling about our own project, QED, of course. So I mentioned before that we have this issue with Doge where it only is a 1 megabyte block, right? So with a 1 megabyte block, we really can't scale things up. Oh, by the way, those seats over there, if any of the standing room only folks want to, yep, your call. But yeah, so we have these 1 megabyte blocks. We can't fit that many transactions inside. But for the vision of Elon, right, we want to make it the people's currency. We want to have millions of people transacting on Doge in parallel. How can we do that? Well, we need to have some kind of a different state model which guarantees something like there won't be race conditions between users so that we can process transactions in full parallel. And again, we want to prove everything end to end. In our QED, we also support multiple zkVMs. So you can write smart contracts in JavaScript, TypeScript, EVM, whether it's Viper or Solidity. Do people use Viper anymore? Anyone using Viper? Viper? You know that EVM lane that had that critical vulnerability in it that no one uses any? Oh yeah, you can use Viper if you want, but Solidity works. But yeah, we've got Rust, and the really cool thing here is that we prove everything end to end. So again, there's no multi-sig, there's no centralized sequencer, there's no weird person that you have to trust. In fact, you can prove your transactions locally. And the key thing here is that our block times are O of log n. And that means that it only takes, 8 times longer to prove a million transactions than to prove 100. So what does a QED block look like? So how do we achieve this massive parallelism? Well, on QED, users prove their own transactions. So you can see the users are proving their transactions in parallel, they're making updates to the state locally, and then they generate a ZK signature with their faker wall, submit their transactions off the chain, and then we build a tree of proofs, which culminates in a single succinct proof, which is then verified in the Vault 16 proof, that is then sent off to Dogecoin. So we've tested on AWS with a ton of relatively cheap nodes. We don't have that much money, but yeah, with I think it was 50,000 concurrent instances, we hit 100K or 200K TPS. So that's also good. On top of that, if we look at the way that QED's proving works, you prove your transactions locally. And the cool thing about that, since we have guarantees against race conditions between users within the same block, we can allow users to prove as many transactions as they like and all wrap it in one proof. So it's not just that we can do 100, 200,000 TPS, we can do 1 to 200,000 UOPS. And each one of those users can be submitting as many transactions with whatever complexity you want, right? Because you're proving it locally, the proof is going to be the same size at the end. If you want to spend time, calculating the 1 trillion digit of pi and prove it on chain, you could do it, right? And your gas fee is going to be exactly the same. So yeah, 1 gas fee for unlimited transactions. Of course, you do have to pay if you modify a bunch of state values. You do still pay for state value, but if you imagine, let's say I'm doing payments for my company and I'm mutating my balance, it's a lot more lightweight, it's a lot cheaper. But yeah, this is just kind of how our block aggregation in parallel works. You can see that we take 4 proofs and recursively verify 1 proof, and then we take those 4 proofs that we generated, verify 1 proof, and then we have the end result. If we count the time p that it takes to prove those, it's 2p for 16. We all know 4 squared is 16, right? So yeah, so for a 1 million transaction block, it takes 300 milliseconds to do the 4-to-1 recursion. on like my MacBook. And it takes, so in that case, it takes about like 2.89, roughly like 3 seconds to generate a 1 million transaction block. Of course, the proofs are like 20 kilobytes, so there is some network time. Fortunately, at 20 kilobytes, it does fit in one nice TCP packet. So like, let's add another 100 milliseconds there. We're looking at 4 seconds per million transactions instead of 3, which is still pretty damn good, right? But yeah, QED also has this really cool thing called programmable smart signatures, which means that you can use your existing Ethereum or Bitcoin wallet to sign transactions on QED. And I'm not just talking about you can use that same elliptic curve key. No, with QED, we can actually support whatever signing scheme your existing chain is using, because on QED, your public key is actually the hash of the verifier key of an arbitrary zero-knowledge circuit. So you can program whatever logic you want, make it a multi-sig, make it so that you need, I don't know, I need to prove that I haven't made a transaction in the last 10 minutes, or I'm only using this contract. And you can write all that logic in these nice, we call them smart signatures or smart keys. It's sort of like a smart contract decoding interface. And yeah, you can really code whatever logic you want. And this is really cool for agents, right? Because I can make these autonomous bots that, let's say, are only allowed to call these functions on these contracts under these conditions, because the smart signature is also aware of the state of the chain. And that allows us to do some really cool things, like allowing applications to define their own custom sequencing rules, support like, other L2s, the L2s on Doge by just opening up a contract or creating a user on QED. And we can also enforce, this is the key here, we can enforce intents and covenants across users. Because we have hard guarantees against race conditions between different users within a block. One of the downsides of that is that certain inherently serial applications are difficult to build within that model. This makes it much easier. We just make a bot user that's going to crunch through one contract and needs to follow, let's say, fair sequencing rules, no sandwich attacks, pseudo-random ordering. All this you can code in your smart signature. So what does all this mean, right? I just blah, 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 right? But the reality is that with QED, and referrers of course, we can compute anything on Dogecoin that we want. And we can do it at credit card scale. So if we want to make a Visa with this kind of a model, we can do it. And we can do it today. So we get such DeFi, many dApps, much stablecoin payments, very games, wow, support for ETC and BTC wallets. And of course, we get our 1 megabyte blocks unchained. Miners are happy, node runners are happy with infinite scalability. Okay? So, and wait, we forgot the most important thing of all. Turn off your phones. We forgot the most important thing of all. All with the same security Dogecoin has today. Not your keys, not your crypto, right? Yay. Right? And as a closing thought, a lot of people talk about scale and kind of laugh off, like, oh, haha, so many TPS, blah, 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 right? First of all, we've demonstrated on AWS, and I realize other people have scalable blockchains, but to have a secure, hyper-scalable, like decentralized, trustless computer is actually a really, really cool thing. And in our industry, we often get distracted by trends, and I know I have as well. But like, if we look at it from sort of a high view, the impact of any technology is proportional to how scalable it is. Because every time we have a technology that impacts someone's life, we're just doing humanity we're giving humanity a little bit of a boost. So if we multiply that by the number of people that can use our technology, that's going to be our impact on the world. And we need a trustless and provably fair internet. We all know how things are going. Maybe there's some platforms that censor more than others, but we're kind of headed in that direction. And we need something that can scale, and yeah, scaling is not a narrative. It should be a responsibility of our industry, especially given the amount of capital that has been invested in all of us, right? Humanity has given us $1 trillion, right? We can't just make applications for us, we have to make it for everyone. So yeah, and we hope that everyone can come along the journey and build other layer 2s, even compete with us, build applications, and just do everything for the spirit of Doge. Yeah, thank you guys. And follow us on Twitter, I have to